Welcome back to today's episode of Miss Max Academy. Let's take a moment and read the prompt. A high school counselor was interested in finding out how well student grade point averages, GPA, predict ACT scores. A sample of the senior class data was reviewed to obtain GPA and ACT scores. The data are shown in the table below. I know on your worksheet it says at the right, but I didn't have any room. So clearly I put the table right here. And if you wanted to take a minute and enter that data into your calculator, we will be talking about how to use our calculator at the end of this short video. How would you know which list to put in list 1, your X values, and which to put in list 2? It's pretty simple. If you take a look here, it says GPA predicts ACT scores. And just a reminder, in AP Stats, X always predicts Y. So GPA would be your list 1 or your X1 values, and ACT would be your list 2 or your Y values. Okay, so here we're given a computer printout. So right now we're going to be using our computer printout to answer most of our questions. Notice they tell us that the dependent variable, and again, Y is our dependent variable or our response variable, is ACT score. So that means ACT scores depend on GPA. If in fact we reject the null hypotheses. So let's take a look at the prompt. Is there evidence of an association between GPA and ACT score? Test an appropriate hypotheses and state your conclusion. Well, I know you guys are going to be very excited to hear this. In general, the free response questions on the AP exam always state that all conditions for inference have been met, and therefore you do not have to state the conditions when performing a hypothesis test or creating a confidence interval for linear regression. Woohoo! Pump it up. No conditions. There are conditions, but they're very different than the conditions we've studied and often confused. So I think that's the AP test's way of saying, okay, we're just going to say all conditions have been met. If the prompt asks whether the linear model is appropriate, then check the plot of the residuals, which we will be doing today in class. So again, all conditions are met, therefore we can proceed with our hypotheses test. So over here at the top, it says step 1, write the null and alternative hypotheses. So, there we go. What's nice about the test for inference for linear regression is the null is pretty much always the same. There is no association between the two variables. So the null is there's no association between GPA and ACT score. And the parameter we use is beta, the capital B, the capital Greek letter B. And again, this is the parameter for slope. And if there was no association, the slope would be 0. And the alternative in this case, because they ask us, is there an association, would just be there is an association between GPA and ACT score. And that would be the parameter is not equal to 0. So we know this is a two-tailed test. Okay. Step 2. We're going to find our standardized test statistic. And in this case, our standardized test statistic, again, is a t-value with n-2 degrees of freedom. Okay. And if you take a look here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pairs of data. Therefore, our degrees of freedom would be 15 minus 2, which is 13. And that does say that here in our computer printout with 15 minus 2 or 13 degrees of freedom. Okay, again, our standardized test statistic can also be found in our printout. And our standardized test statistic is this number right here, 6.80. It is the T statistic for GPA, okay? And again, we're testing our slope. So that's, again, we want to make sure we're testing our slope. In this case would be, let's see, it's rise over run. So it would be how much ACT score improves based on GPA. Looking at this association, it's clearly a positive association, okay? And I just wanted to use the formula on your Chapter 27 notes. And the formula is B subscript 1, which again is the slope of our sample. And the slope of our sample is right here, 7.39697. That's the slope of our sample. And we divide that by the standard error of the slope. And again, the standard error of the slope. This entire row right here is all information about slope. Here is the coefficient of our x variable, which would in fact be our slope. Here's our standard error of the slope, and here is our t statistic. So again, all this information came from that same row in the computer printout. Okay, excellent. And just in case you were wondering, what does this number 1.087 mean? The standard error of the slope is how much the sample slope typically varies from the slope of the population. This is the value we use in creating our confidence intervals and obviously finding our test statistic. Okay? All right, so let's move on. Okay, so step 3, we're going to state the regression equation. And again, in Algebra 1, we learned y equals mx plus b. It looks a little different in AP Stats, not too different. In AP Stats, we say y hat equals b naught plus b1x. Again, b naught is our y-intercept, b1 is our slope. And make sure we write the regression equation in context. So we should have the predicted ACT score is equal to negative 0.427 plus 7.397 GPA. Again, let's go back over to our computer printout. Here's our slope, and here's the coefficient of the constant. Well, our constant in this case would be the y-intercept. So that number negative 0.427 is this number right here. Okay, so we've stated the regression equation in context. The predicted ACT score is equal to negative 0.427 plus 7.397 GPA. Moving on, step 4, we're going to find our p-value. Our p-value again is given in that single row here in our computer printout. And this is our p-value. Our p-value is 0.0001. This is a two-tailed p-value. So luckily for us, our test is already set up for a two-tailed test. So our p-value here is 0.0001, which we know is, of course, very, very, very small. So our last step is obviously to write our conclusion. And the first step, with a p-value of 0.01%, which is much smaller than an alpha level of 5%, and again with a small p-value, we expect that we are going to reject the null hypotheses. So if we reject the null hypotheses, we always write our conclusion in terms of the alternative. And here's what our conclusion should say. There is evidence of an association between GPA and ACT scores. The regression equation indicates that each additional point of GPA corresponds to an increase in a student's ACT score by about 7.4 points on average. And that concludes our hypotheses test for inference of linear regression. Actually, I think I've decided to show you a few things on the calculator. So let's go back here. Everybody should have entered their data, correct? So let me flip. What would the hypotheses test for a linear regression look like in our calculator? Well, first we have to get to the right key. So if everybody could just take a minute and press the stat key on your calculator. And we've seen that key many, 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 many times. And if you arrow over to tests and you arrow up to linear regression t-test. I mean, it doesn't matter which arrow, you can arrow up or down, but it's quicker if you arrow up to get to linear regression t-test. Okay, so then you're going to hit enter. And you get a menu that looks like this. And it says our X variables are in list 1. Of course, you can change that, but I think we did put our X variables in list 1. Our Y variables should be in list 2. And again, you could change this if you needed to. Our alternative hypotheses is not equal to 0. This tells us we have a two-tailed test. And then we're just going to hit arrow down until we get to calculate and hit enter. Okay? So our next screen looks something like this. And notice our equation is in the form y equals a plus bx. That's a little different than what we saw in Algebra 1, but that's all right. In AP Stats, we would say y hat, the predicted y value, is equal to b naught plus b1x. So again, this b1 value is our slope. And this b naught value is our y-intercept. So where would we find those pieces here? Oh, okay, so they said a is our constant, so this is our b naught. They said b, which is the coefficient of x, is our slope, b1. Okay, so the equation from our calculator would look like this. Our predicted value is equal to negative 0.427 plus 7.39x. And again, in AP Stats, it's not enough to just have the x and y's. We would generally put it in context. And I remember that this is ACT score. Our predicted ACT score is equal to negative 0.427 plus 7.39 GPA. Excellent. And what does this S right here stand for? Well, if you look at the back of your Chapter 22 notes, you see that computer printout, and I identify S. S is the standard deviation of the residuals. This is our typical prediction error. On average, this is how much your predicted value differs from the actual value. So this represents, on average, how much our predicted value differs from the actual value. Notice we have an arrow down, so let's arrow down and see what else there is. And here we have our degrees of freedom, which we always would report with any t-test. Again, this is just our y-intercept and our slope. But here we're given r squared, and just a reminder, r squared is the percent of variability of y accounted for by x. So 78% of variability in ACT score is accounted for by GPA, right, by your grade point average. And obviously if we have r squared, we can find r. It is just the square root of 0.7807, which is 0.88. And again, R tells us the strength of our linear relationship. The closer R is to 1, the stronger the linear relationship. All right, see you soon. Tune in again for the next episode of Miss Max Academy.